Okay, let's now continue our look at little bit more complex if statements. All right, now we have a spreadsheet here. Confusing looking spreadsheet, I might admit. But let's see if we can make some sense of it. Now this spreadsheet is compiled from an SBA. All right. And for this SBA, we have a program that's going to loop 10 times, a for loop. So you can say 1 through to 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we can pick that up right away. Here are the names of some patients, where we have pat name, tot, and so on, because these are the variables as we used them in our program. When you're going to build a trace table, one of the first rules you pay attention to is the headings of your columns must be the same variable names. Let me speak like an American right now. Must be the same exact. Yeah? But let's not do that. That sounds really off. Alright. Must be the same variable that you used in your program. Because what a trace table does really is to check your program to ensure it's producing correct results. In other words, free of logic errors. Remember we mentioned that before. Syntax errors prevent your computer program from running. Won't compile. Alright. Get compilation errors. Now we do trace tables to get an idea of what the result should be when we create a program, what the output should be, what the results of our program should be. Now in this case we have 3 districts. We have Exchange as a district, we have Great Pond, we have Buckfield. Well, I realize sometimes that these are 3 districts that I've lived in actually. Alright, so these are 3 districts that we're going to be totaling up the amount each person paid from the district. So we're going to add the 700 Exchange here to the other person's amount for Exchange here, and then we go again. So each district we're going to add them based upon the district from which they are, or which whatever clinic they visited. All right. So we won't add Exchange and Bucksfield and so on together and Great Pond. No, we're going to add them separately and count separately. So as a result of which, we need a variable tot b, which is short for total for Bucksfield. So total Bucksfield is going to add up for Bucksfield. Total and the count, B count, Bucksfield count is what we're doing here. So we're counting Bucksfield, the amount of entries entered. So first Bucksfield person entered here, that's why we have 1 here. Alright. The next person for Bucksfield entered here, that's why it's 2. And so on. For this one, Bucksfield, the first person for Bucksfield would enter that loop number 3, Buckfield. So the first person was counted here and the total is 600. When we go a bit further, the next person for Buckfield was entered here. So therefore person 2, and it also was 6 persons. So 2 persons now. So it's 1 plus 1 is 2. The second person entered. And the 600 plus the 600 here for Bucksfield now becomes 1200. Then the final person for Bucksfield was entered here. Not surprising enough, it's 600 again. Alright, so it's 3 persons now, and it's 1800. Now we go to, let's say, for example, Exchange. Alright, so Exchange is here. So what we do now is this. First person entered in Exchange, 700. Now it continued at 700 all the way down because you entered the different districts or so on, without Great Pond here or Bucksfield here. But the second person for Exchange was entered here. So now what we do is 700 plus 800 becomes 1500, and the second person was entered. Now we come down, Exchange entered again here. Then we look at the third person now being entered, and this person paid 700. So the 1500, the last entry at Exchange, the last total, 1500 plus now somebody came into Exchange or registered for that place. So as the 1500 plus the 700, now it is 2200, 2200, and the third person entered. Same principle for Great Pond, because now over the extreme right over here, in the very first loop, nobody was entered for Great Pond. Alright, they were entered for Exchange. That's why the 0 is here, and the 0, 0 is also here for Bucksfield. However, in loop number 2, x equal to or x becomes 2, somebody, one person was entered and they had 500. They paid 500. Now for the next three loops, loop number 3, 4, nobody was entered. That's why I say 500 coming down still, and 1 over here. Then at the sixth loop, or fifth loop I should say, somebody was entered for Great Pond and they were paying 900. They paid 900. So it's 900 plus the 500 equals 1,400, and the second person was entered. Keeps coming down because the balance was the same, coming down until a third person was entered at loop number 8, and this person paid $500. The 500 plus 1,400 became 1,900, and a third person was entered. And the final person was entered now at $800 for Great Pond, Mighty Mouse, and the fourth person was entered, and the 1,900 plus 800 became 2,700. So at the end of it now, these are the totals per district for the amount of money paid plus the number of persons who visited. B count, and the total, top B, for Boxfield. Total for exchange, tot E, is 2,200, as well as the total number of persons entered for exchange, E count, exchange count, or counting, as you may say, 3 persons. And tot G, total for Great Pond, all right, 2,704 persons. So this is basically how the trace table would look for this program that you really have to look at to get a good feel of. So here at line number 3, we are saying here that these are the patient name. We declare pat name, patient name, and the district as string. District basically meaning Boxfield, Exchange, Great Pond. Fine, fair enough. At line number 4, we're now saying the X, B count, Boxfield count, E count, Exchange count, G count, Great Pond count as integer because we're counting. These will not be, we're counting by whole numbers, 1 plus 2 plus 3 plus 4 plus 5. And the total, these are totaling money amount, dollar amounts. Hence, we put them as real because you might have dollars and cents. It's only for purposes of space on my spreadsheet why I formatted these to no decimal place. But you can see why decimal place would be necessary, dollars and cents. All right. So that's why this is set to real. All right. So now we run our program. So at line number 8, we're basically saying our counter for x therefore equals 1 to 10 do begin. So x is our counter. Hence, you see x as the counter to traverse the loops in our loop construct for our trace table. So each loop represents an entry, one entry. All right. That is why sometimes, for example, if in line number 1 here, somebody was entered for exchange first. Runkus Ricketts was entered for about exchange. Yeah, exchange, yeah. Somebody was entered for exchange at $700. So therefore, exchange is 700 and 1 person came in. While the other 2 districts, Boxfield and Great Pond, are still empty. All right. So let's continue. So let's say Runkus Ricketts is entered first, and the total he paid was 700, and the district was exchange. All right. So now the program goes and check. If district equal Boxfield, then do this here. But it couldn't do all of this. Why? Because the district is dependent upon this test. And it's not true. It's not Boxfield that was entered. So it would skip all of this because Boxfield was not entered. So it go and else if district equal exchange. Was district equal exchange? Yes. Because you see, Runkus Ricketts entered exchange 700. All right. So it would then execute this set of commands and then go back around and check and, continue the loop, not check, to go for x to become 2, which would then become the second loop, and then the program continues through the loop process like that. So the next person that was entered was Malvina Morris, right, for 500 at Great Pond. So at loop number 2, it would go through and say, okay, fine, Malvina Morris was entered at Great Pond. So I check, is district equal to Boxfield? No. So it goes, else if district equal to exchange? Still no. So it goes and check, else if district equal Great Pond? Yes. So then it would now go and enter 500. Now this is loop number 2, as we're seeing here. So to enter Malvina Morris, 500 for the total so far, because it was 0 all along because nobody was entered in the loop in the program so far for Great Pond. The first person entered was Malvina Morris at loop number 2, and 500 the total so far, and 1 person entered, and it would continue. Now the third loop, somebody was entered for Buckfield, and if it was 0-0 all the way, 1 person entered for Exchange, 1 for Great Pond, and we're at the third loop before somebody was entered for Bucksfield at $600, and that's why Buckfield is just starting at 1. So let us try out this now. I hope I don't have any errors in this program, so I have to stop and correct anything, but let us see how it works. And I'll correspond with this trace table to ensure that we get the same totals here at the end of the program, as in total for Bucksfield 800 and 3 persons, total for Exchange 2200 and 3 persons, and total for Great Pond 2700 and 4 persons. All right, so because this is what our program should produce for us at the end to make sure. Now a good thing to do is that if you're writing a program, and let us say what if you have 1,000 persons to enter, check it for 10 or 5 or even 50 if you wish, but 50 is a lot. Once it's working okay for the 10 persons in all the relevant district or sections, then you can reasonably conclude it would work the same way when you scale it up to loop 1,000 times. All right, now let's get to this. I'm going to have to come back and check here with this trace table every now and again to make sure I'm entering the correct data so that we get the right totals here at the end. All right, at the last part of the loop down here. All right, let's get to work. So is RR, I won't bother to type in all this, guys, trust me, too much work. So I'll just put the initials. All right, so I'll put RR 700 Exchange. All right, so let's run this program. Run. So they give me some stuff, but this wasn't initialized. I'm not concerned about that right now. It says RR and 700, and it's from Exchange. Now I must spell Exchange exactly as how I spelled it in the program here, or else it's going to give me some problems. All right, press enter. And so far we see Exchange 700, number of persons entered is 1. All right, fine. Next person is Malvina Morris, Great Pond. All right, and is 500. So MM 500 Great Pond. So is, let me move it most of the way. So it's MM 500 and is Great Pond. All right, that's now 1 person entered for Great Pond, and we are going to the third loop now. All right, so now we can see the corresponding information here. So going to the third loop now, GG Buckfield at 600, right? So it's now GG and 600 as now Buckfield. Did I enter Bucksfield or Buckfield? I should use Buckfield, right? Buckfield, which is spelled properly. Right, so 600 number of persons entered is 1. Now we have done 3 loops. Let's go back and see again who is left, where we're going to go next. All right, so we are at loop number 4 now. We are at Ludlow Lawrence, 800 Exchange. Says LL. Says LL. All right, and then it paid 800 and is Exchange. All right, and we're at 1502. So far everything seems okay because Exchange is actually 1502. So the corresponding information here, good. So we are working okay so far. Then we have PP Finky Plunkett, Great Pond 900. So PP 900 Great Pond. So is PP 900 and is Great Pond. it's good to use small numbers when you're doing this so you can actually pick up to see how correct it is. Something you can add mentally, don't need a calculator. So if you're working with small numbers that you can leave 1, 2, 3, 4, 9, 15, so they can add quickly, it will work for the larger numbers as well. Alright, so therefore we continue 1400 2 persons for Great Pond. Let us see where we are. So Great Pond, right, 1400 2 persons. So we're good so far. Alright, and where are we now? We are now at PP again, Boxfield, 600. So PP, 600, and now we're at Buckfield. Oops, Buckfield. All right, and there's a baby crying outside. I wonder what happened to her. All right, and then there's now 1202 for Bucksfield. Let's continue. All right, and Mowgli Mendez, MM, 700 exchange, right? So it's MM 700, and this is now exchange. All right, and that's now 2200, and it's 3. Now let's look at this. Right, so far we are on track. 2200 exchange. Here we are, right in this section here, right? And now we have VV Great Pond 500. So is VV what is it, 500? That's what I said. 500, don't remember. Been just run away a while ago. 500 VV 500 Great Pond. Alright, cool. 500, and we have Great Pond, and here we are so far. That's 3, and we're coming close to the end now. We have Fancy Cat 600 Buckfield. So we have FC Fancy Cat FC, all right, 600 and Buckfield. All right, before I press enter, let me go back and check. I want to make sure. Cool, good. So press enter. Now we have 3 persons entered for Bucksfield, and it's 1800. So let me see, Buckfield ended at 1800 for 3. All right, and now the last person is Mighty Mouse Great Pond, 800. All right, so now is MM. Oops. So now is MM Mighty Mouse, and is 800, and the Great Pond, and that ends our program. So Great Pond end with 2704 patients, and when we look back here, we see 2704 patients. So our program did indeed work correctly. So this is something you have to pay attention to. If you are going to do total and counting, so those skills that we spoke about before, we spoke about accumulating and counting, we have used all of them now with the loop in an if statement. So it's now the culmination of this. This is the last video regarding Pascal, and now we realize that if you're counting per district, per section, so if you're counting per parish in Jamaica, and it's 14 parishes, you have to have 14 count variables. And if you're going total again, you have to have 14 variables for totaling. So you can get the program to 1 count, and 2 to give the total per parish. And that's a lot of variables. Because we're not doing arrays in the 60 syllabus, you know that does just complicate life. Alright? So if we're doing arrays, it could be a lot easier. But this is what we're working with. Alright? In our programs. And remember what you have to do. Alright? So that's it. And this is our final statement and our final, because we include everything here: accumulating, counting. We are also doing if statements. We're doing loops. Everything in this final video for Pascal. So I hope that's clear for everybody. I hope you understand. You can watch this over and over as many times, and I hope you at least pick up I try to make them as coherent as possible, with a seamless transition from topic to topic. building it up like a scaffold. All right. So I hope that benefited you guys, and I hope you have a better idea of how to write in Pascal language. And if you can't write in Pascal, you can write algorithms, is not a problem. Pseudocode is not a problem. All right. And oh, I might want to put this in as well. This end semicolon here, what do you think this end semicolon is doing? This one right here at line 39. It's ending this if statement. Notice our indent. If the line here, and I come right down to if, this if semicolon, if semicolon here, this end semicolon. So this end semicolon is ending this if state, all this if statement here. It's ending all of this if and else if. It's ended right here. This other end semicolon, note these end statements as well. End, ending each subsection of the if or else if. All right. And this end semicolon here is ending this entire for loop. So this end semicolon is ending the for loop. And of course, you know what this end full stop is about. Ending the whole program. So that's it, guys. I hope you found this informative. I hope it helps you and so on. I think we should be doing arrays. I would hope so, because it will save us a lot of time with all these whole heap of variables and so on. But it's no longer on the 60 syllabus. So we won't be doing that. Have a good one, guys. Please watch as many times as you feel like. If you want, like, subscribe, because I know the videos that don't get much likes, I'm going to take them down. I'm going to assume that they're not really working the way I want them to, and try to redo them and put them back up. Alright, so hope this benefits you. I hope you really learn. But remember, the only way to learn to ride a bicycle is to practice, to ride. Swimming, same thing. If you want to learn to cook, you have to go in the kitchen. You might get burnt a couple of times, you know, or splash out on you sometimes, but guess what? Or you're holding your little mitt, the baking tin, but sometimes if you don't have, can't find them, you put a cloth around your hand and it might slip. You get a little burn on your thumb or your finger. Yes, it takes time. It takes effort. The only way to learn to code is to make the mistakes and learn to correct them, because you are going to make mistakes. Most of these videos, as you realize, to save time, because I realized I was going longer and longer, I wrote the code before, I tested them, and then do the video. Because I made a couple errors. Sometimes I had top B here because I copy and paste, which I shouldn't do. You know, it's a bad habit. Shouldn't copy and paste. But you know, to save time and you're rushing, so you make a little mistake here or there. But becoming a good programmer is learning to correct your errors. You have to be patient and learn to correct your errors. And as you go along, it gets easier and easier. As you see, you pick it up. And practice makes better. You may not get to perfect, but you will get better. Have a good one, guys. Take care.